Hello, welcome to the video. In this lesson, we're going to be looking at section 5.2, where we're going to be looking at congruent polygons. So what we have is we are going to be given essentially two shapes that are exactly the same. Now, the only way that we can um, identify that those shapes are the same is we have to look at one of two things. First, we'd have to look at the congruency statement that is given to us. Second is we have to be able to identify um, corresponding angles and corresponding sides of those congruent statements. So, for example, what we have here is two triangles that give us enough information to tell us that both of them are congruent. Okay, the hash marks in both the sides and in the angles tell us that they're going to be congruent. Okay, so if you look here, like with like vertex K, it has three dashes for the angle. Another one that has three dashes would be S. So what we can say is if we were to look at the corresponding parts for this is let's take a look at the angles. So if I look at the angles, I could say that angle K is congruent to angle S because of the hash marks. I can also say that angle J is congruent to angle T. They both have two hash marks. And then finally, I can say that angle L is congruent to angle R because it has one. Now, looking at the corresponding sides, we use the hash marks also to determine those as well. So like I see that line segment JK is going to be congruent with line segment ST. All right, so they have the same one hash mark. The one that has two hash marks would be LK would be congruent to RS. And then finally, we can say that the 3-1, so it would be what JL would be congruent to RT. And you could kind of flip the letters around. Like you could say like this is TS if you wanted to, but I attempted to try to make them in alphabetical order if I could, but it's not required. So that is being able to identify the corresponding parts of two congruent figures, more specifically, these two congruent triangles. All right, so now we get to write our congruency statement. So our statement in this case, now we have to be consistent with the order, like usually what it would be is the order of the first one is going to have to kind of line up with the second one. So I would say it's probably easier to kind of look at the angles in this particular instance. So like let's just say I said triangle KJL. So KJL is going to be congruent with triangle STR. All right. And so I just kind of wrote that with the corresponding angles. All right. Could these, um, could this congruency statement be written differently? Sure. You could write it another way and say like, oh, triangle LJK would be congruent to triangle RTS, and that would also work as well. But you remember you have to keep consistent with your corresponding angles and the corresponding sides for the congruency statement to be true. Okay, you can't change the order of the of the statement without changing the order of the other one with respect to its corresponding angles and corresponding sides. So looking at this problem here, it says in the diagram, DEFG is congruent to SPQR. So they gave us a congruency statement. So since they gave us a congruency statement, I can automatically now make the assumption that the corresponding angles are congruent and the corresponding sides are going to be congruent. So we're going to use that information to help us find um, these particular unknowns. So here they want us to find the value for x. So right now I see I have x in this problem, but I also see I have x in this problem here, or in this side measurement and that angle measurement. Because I have two unknowns for angle Q, I'm going to start off with trying to find x with QR. So QR is the third and fourth term in this congruency statement. So it's going to line up with the third and fourth term in the first diagram, and that is FG. So I can say that FG and QR are the same. So in order for me to find x, so I can say that, well, 12 is going to be equal to 2x minus 4. I add 4 to both sides, so I get what? 16 is equal to 2x. X is equal to 8. All right, so now that I know that it is 8, I can say that angle Q now is 6y plus 8. And Q is the third letter in this statement, so the corresponding angle for this would be F. So F is 68 degrees. So now I can say, in order to solve for y, I can say 68 degrees is going to be equal to 6y plus 8. So now to solve for y, subtract 8 to both sides, I get 60 is equal to 6y, divide everything by 6, y is equal to 10. So that's how we can solve for both x and y because of the congruency statement that was given to us. Okay, so here it says in the diagram at the left, they want us to show that triangle PTS is congruent to triangle triangle RTQ. All right, so they wanted to show it. They gave us a congruency statement, a possible congruency statement. So we will, since all they gave us was, looks like they gave us congruent sides. So I want to see if all three corresponding sides are in fact congruent with respect to the order in the congruency statement. So just by looking at this, I'm going to say first and second, I got PT. I want to see if that is congruent to RT. So when I look here, PT is 3. Does RT have 3? Yes, it does. So I can check that off and say those are congruent because it's given. Next, I'm going to look at second and third. So TS, I want to see if that is congruent to TQ. So TQ has 2, TS has 2. I can check this off. Yep, that is given. And then finally, first and third, PS, is that congruent to RQ? So PS is 1, QR is 1. Yep, that is given. So I have determined that all three corresponding sides are congruent. Since all three corresponding sides are congruent, I can say yes, triangle PTS is in fact congruent to triangle RTQ. Now, there are some there's going to be some triangles that will be congruent, but sometimes they don't give you all the information. So we have to use some theorems, some properties to assist us in either validating that a triangle is in fact congruent or proving that a triangle is congruent. So we've seen these before, reflexive, symmetric, and transitive. These properties should be relatively straightforward. You can review that. Also, another theorem that we can use is a third angle theorem. So if you have uh, two congruent angles, um, you can assume that the third angle is congruent by this theorem. So with that being said, we have some information here. So in this particular one, they want us to find the measurement of BDC. So BDC is actually located right here. So BDC is right here. So I want to find that red angle. So they do give us some information. So this hash mark here with angle A is the same as angle B. So I can say that this is 45 degrees. I have two hash marks with 30 degrees, so this portion right here is 30 degrees. What I really don't know is what x is right here. So if I look at triangle BCD, all the interior angles using triangle sum theorem is going to be 180 degrees. So I can say that one side, so it's going to be 30 plus another not side, another angle is 30 and another angle is 45 and another angle is 30 plus x. Those are going to result in a 180-degree angle because of the triangle sum theorem. So if I added all those up, I would get 30 plus 45 plus 30, I get 105. So 105 plus x is equal to 180. Take 180 subtracted by 105, I get x is 75. So x is 75 right here. But to find this angle right here, I'm just going to take and say, oh, the measurement of angle BDC is going to be equal to 30 plus 75, which is 105 degrees. So here, it's asking us to use the information in the figure to prove that triangle ACD is congruent to triangle CAB. So what I want to do is I'm looking at these corresponding sides. So first off, I want to know, so I got first and second. Does AC, is that congruent to CA? All right, if you notice that they are just flipped. So basically they share this side of both of the triangles. Since they are the exact same line segment, I can say yes, they are in fact congruent because of the reflexive property. Okay, so that's one. Next, second and third, CD is congruent to AB. So CD is 2, AB is 2. Check, yep, that's given. And then finally, second and third, I'm sorry, I already did second and third. First and third, AD is congruent to CB. AD is 1, CB is 1 hash mark, so that's checked off, that is given. So all three corresponding sides are congruent. You can even look at the angles. So AC, second, um, C on this side, A on that side, first and first, and then third angle theorem gives you D and B. but I just did the corresponding side, so that works out. So I can say yes, that triangle ACD is congruent to triangle CAB. Here we have a diagram to our right. It says, first they want you to find DCN, which is this angle right here, okay? So since they're telling you that it got a hash mark with 68, so S and D are going to be the same. You can, if I looked at this triangle right here, I know because of the triangle sum theorem, I know that um, 180 is going to be, if I subtract it by 68 and I subtract it by 75, I know that this is going to be 37, all right? I also know that this is also going to be 37 because they are vertical angles. So since this is 68, that's 37, I know that this one is going to be 75 degrees because again 75 plus 68 plus 37 gives you 180. So I know that angle DCN is 75 degrees. The second question on here asks us what additional information is needed to conclude that triangle NDC is congruent to triangle NSR. So if I just looked at the sides, so so if I went first and second, is there a way to show that ND is congruent to NS? So ND is right here and NS is right here. There's no hash marks. So I'd need to know that. I need more information. Next, if I said DC, is that congruent to SR? DC is right here. SR is right there. I would need more information. And then finally, I believe NC is congruent to NR. NC is right here, NR is right there. That is given. But I would need more information about these two. I need to show that ND is congruent to NS, and I'd also need to know that DC is congruent to SR in order to make the conclusion that those two triangles are congruent. And that is looking at congruent polygons. Hope this helps. Till next time.